So good evening, everyone. This is yet another episode of Sunday webinars by Welcome Solutions. And in these webinars, we talk with interesting people with interesting careers, often also holders of PhD title, but not only, and people who made interesting career decisions and career transitions in their lives. And today I have a great pleasure to welcome Alican Noyan, who will tell us a little bit about his personal story and his transition to industry. And briefly about Alican, Dr. Noyan has a background in material science, and that's very interesting because I would like to learn about material science myself, and I would like to hear a little bit more. And Alican went for an industrial PhD program at Hewlett Packard in collaboration with the Institute of Photonic Sciences in Barcelona in Spain. And during his PhD, he developed and fabricated a novel self-cleaning surface for Hewlett Packard. After his PhD, he continued working at the Institute, developing machine learning models for several photonic research projects. And today, he works for his own company, Ipsumio, where he uses machine learning to solve problems in physics and healthcare for research groups and companies. And I'm very happy to welcome you, Alican, today. And like one comment I would like to make, guys, if you're watching this episode and you like the content, then please remember to subscribe to the channel and also leave some comments. And if you have any questions or any comments for the content that you just seen, then please leave it under the movie. We'll screen through everything and attempt to answer every question with Alican. So thank you so much for that. And now I would like to give the floor to our guest so that he can introduce his own story with his own words. Thank you so much, Alican, for accepting our invitation, and please tell us how your story looks like from your perspective.
Hello. So thanks a lot, first of all, Natalia, for inviting me. Actually, you explained quite a bit about what I did and what I'm doing, but as you said, let me explain, maybe give more details about my story. So I'm based in Eindhoven. I'm living here, and I founded Ipsumio a year ago together with my business partner, Emre. It's a machine learning company. And as you said, I started as a material scientist and totally switched to machine learning. So I will explain a bit about the road. So after graduating from my bachelor's degree, I started a master's on nanotechnology. At that point, I decided I wanted to do a PhD, but that academia is not for me. So what I was searching for is an industrial PhD, basically. And luckily, I found this program in Barcelona by the Catalan government. So they were bringing together companies and universities, institutes, to solve the R&D problems companies are facing. In my case, it was a project together with HP in Barcelona and ICFO, my PhD institute. As you said, it was related to printers. So HP has a very large facility in Barcelona. They have both inkjet printers, 3D printers, and the challenge they faced was the contamination inside the printer. So they have lots of sensors inside, and these sensors get contaminated by ink, by powder. So what we developed was a self-cleaning surface to clean the sensors. And this was pretty exciting for me, but after the PhD, I decided I wanted to switch again, let's say. I did a little bit of Android development. I decided, again, it's not for me, and I decided to try machine learning. I took a course, an online course, and I realized that it's really, let's say, my calling. So I went to my professor after PhD and said I wanted to apply machine learning to our existing projects in the group. So I worked as a research engineer in the group, still in Barcelona, and combined machine learning with physics, photonics projects. Then, seeing the value there, I decided to build a company around this idea. This is how it got started. And the reason I'm here in Eindhoven is my wife came here to work. So I followed her, and that's why I founded the company in Eindhoven. This is more or less the summary of what I did.
Okay, great. I already have like a list of questions that I came up with while you were talking, because it's very interesting. First of all, you are the first person in the history of this webinar who did a PhD in industry. So that's already very, very interesting. I have to say that I know of these PhDs, and I know a few people who are doing PhDs in companies. But like in the Netherlands, it's not a very often practiced still. And indeed, HP and Philips, those I know that these are companies who host a lot of PhDs, and some others as well. But it's not like when you look at the percentage of like industry PhDs in the whole pool of PhDs, it's not a high percentage. So actually, my first question for you would be, before we talk about how the reality of such a PhD looks like, and don't worry, we will switch to business later, and definitely will ask you about that. But first, I would like to ask you a few questions about how your PhD look like. So first of all, I would like to ask you about this decision to go for this type of PhD, because you said that you already knew that probably research career is not for you before you went for a PhD. So my first question is, why did you take a decision to go for a PhD then, rather than going straight to industry? Can you explain a little bit about that?
Sure. The main motivation was, okay, then if not academia, what should I do? And I was looking for other options. And what I see was to work on a challenging project in the industry. Let's say R&D, like what ASML is doing, right? What Philips Research is doing. So for these projects, not necessarily, but mostly they require PhDs. And for good reason, right? So because actually they are also generating new information. So it's not that industry is, let's say, behind academia in terms of knowledge generation. So they are on par in some companies, let's say, not all, yes, but like companies like ASML who are doing research at the edge, they might be doing even more research than the academia. So this is why I realized that even though I don't want academia, for such a career, I would need a PhD.
Actually, if I can say something here,
Sure.
I think it's really interesting when you look at the numbers of patents granted yearly. Then you can see that actually the leaders are not universities anymore. The leaders are companies such as IBM. IBM is the world leader currently, but also indeed Philips and other IT companies or companies producing equipment. And yeah, and I can see that. And ASML is also very heavy on R&D. Actually, this is the ASML is the company that has the biggest R&D department in the Netherlands. It's like almost 9,000 heads. And and they have so many PhDs that they even have a yearly annual PhD day. So they have the separate fest for PhDs only. So it's indeed, I totally agree with you, and I think innovation in general already a long time ago moved to industry. Unfortunately, academia is falling behind, and so I totally see your point. Okay, and so I understand your point right now. And actually, so my next question would be actually more like motivation wise, since once you do a research project in academia, then it's it's knowledge, and whatever you produce, it's knowledge. It goes is put out there as a research paper. You're the author. You have that feeling of satisfaction. But here, once you produce for a company, there is also another factor, that is money. So if you design self-cleaning surfaces for HP, I'm sure that they probably make quite an amount of income on that, right? Either directly or indirectly. So how didn't you ever had any motivation problems for this reason, that once you work for them, your work is actually producing a fortune for someone else?
It's a very nice question, but okay, this is an important consideration in general, but not for the PhD, because it was kind of a decision. You know this, and you decide to do it, even though that is the case, as you explained. Because if you are playing the long-term game, for 3 years working on a project for HP is okay. I agree with what you say. If you are working for a company for 30 years, then yes, that's not a very, I would definitely have some motivational problems. But for 3 years, it's perfectly fine, because I'm also learning a lot. Okay, not in terms of finances, that's not the best option, but that is the best option to be at the edge that early in my career, let's say, and learn a lot. So that was my main motivation. And in terms of that, so I didn't have any problems.
Okay, interesting. Yeah, I don't know. It's really personal, and everyone has a different attitude to money. It's also your personal. It's also about your personal relationship with money, and how you perceive money, and how you perceive the importance of money in your life, and what type of relations in employers you would accept to have, and what types you wouldn't. And actually, I can see that probably I would have a bit different motivation structure, but this is again very personal choice. Okay, great. And my next question will be very, very practically. How does such a PhD look like? So I'm guessing now that since you probably defend at the research institution, you probably also have some supervisors that work with you that represent that institution. Am I correct?
Yes. So let me explain you how it was. So the company comes you with the problem, right? They say, we have this problem, but we don't know how to solve it. And the role of the institute is to come up with a possible approach to this problem. So I had my advisor there at ICFO, Valerio Puruneri. He was my advisor, and I was. So the working was, we were trying to come up with possible solutions with him. So I'm actively working with Valerio. We come up with a solution. I fabricate it, test it in our lab at ICFO. Then I go to HP and test it inside the printers. So this was more or less how it worked. I was spending most of my time at ICFO in the institute, trying to fabricate a surface, a self-cleaning surface. And once I'm done, I go to the company. We do tests inside the printer. So this was, and then there were engineers responsible from me as well.
Okay, so you had kind of double supervision between the company. Exactly. Okay, great. That sounds really good. Okay, and did you also produce peer-reviewed papers during your PhD?
Yes, exactly. So this was actually, I would say, the main disadvantage of this program, that the focus is not peer-reviewed papers. The focus is solving the problem of a company. So, and they don't care if it's a paper or what. They just want to get their problem solved, right? So, but as I said, before PhD, I decided that I didn't want to go to academia. So that was perfectly fine for me, but it might be really sad for some other people that they cannot really publish. So in my case, we had some initial results that looked good, but it had to go through a company process for the patent application, etc., so that we can publish. So it was not an easy publication in that sense. It took some time to pass the company procedures and then being able to. So they had to let me publish. But also, since this is a PhD, I have to publish. So there was this challenge, but luckily I was able to publish, and then we also have a patent together.
Okay, I mean, I guess that there is might be a little conflict of interest, right? Because the point of the company is to make as much money as possible, but reveal as little IP as possible. Mm-hmm. And science is going into this open science mode right now, and the point is exactly the opposite, to actually reveal all the pipeline and all the every fine-grained detail of the project. So I can imagine it was hard to marry the two worlds together in this setting.
Well, it's actually a trade-off the company has to decide, right? For some projects, they might say, okay, this is definitely, we're not publishing anything from this. So then you don't make a industrial PhD project out of it. But for some, they might say, okay, I mean, we are interested in solving this, but we don't have the internal capability to solve this. So why not outsource this instead of not solving it? And let's see what we can do. So, right, this is like a trade-off in this sense. And
okay.
In this case, it worked out well.
Mm-hmm. Okay, great. Okay, so now let's move to this period of time when you were switching between the two careers. So I'm very curious, since you're not the first person here at the webinar who kind of retrained themselves by themselves using online courses. There was already Andrea Marcus Smith here before who did the same. So he was doing neuroscience, but as an experimentalist. And then he basically took 3 months off I think after his contract expired. But anyways, it took him 3 months to take online courses, and he did it exactly. He did it entirely on himself, and he again he also applied for a job as a data scientist. He's now working in a startup, and he is really successful. So I know recently he let me know that he already got his first promotion after literally like 4 or 5 months working there. He's very happy there. So his transition was quite successful, because he's not only that he landed the job, but he's also appreciated there, and it's mutual appreciation. So so in his case, it took him 3 months. And I was curious, in your case, how did you actually approach this transition, and what was your strategy? How did you choose the courses? How much time did it take you? Could you spill some beans here?
Sure. The first course I took, it was the famous course on machine learning. It's like the first course, if you search Google, machine learning online course. This is the first one. It's from Andrew Wang. He is the also founder of Coursera. So this was a course on Coursera, but he also founded Coursera. So this is how I started. It took a month, I guess, the course. So while I was working, I was taking it after work. So it took a month or so. Then I decided, okay, this is nice. I want to pursue a career in machine learning. And so instead of taking more courses, as I said, I went to my advisor to try to apply this to real problems, because there is no, I mean, you cannot learn really if you just take courses. So this is why I wanted to try to apply it as fast as possible, knowing that I will fail, because I mean, these things you cannot learn in an online course, but you have to start from somewhere.
Yeah.
So this is how I started. So then from that point on, it was always a balance between application and taking courses, and also reading books. I also bought quite a lot of machine learning books, but also like statistics, linear algebra, all these things that help you understand machine learning. So actually I applied more. So it was like maybe, let's say, 66% application, 33% learning, because I try to apply, see where I fail, and then find the related course. Because at that point, you also understand the course much better, because you know why it's important, what it will solve, then you directly apply it to your own problem. So, and to this day, I'm still learning and applying, and this will continue like this for some time.
Okay, I really like the attitude. I think to some extent this is exactly the scheme that Dutch universities try to affect. So I also, when I came to the Netherlands, I was surprised with how much learning through practice they do here. Because in Poland, it's more, when you're an undergrad student, then you get lectures and assignments, and these assignments are usually just closed form assignments. So you have to solve some formula. It's something that doesn't really require like free thinking about the project. It's more that there is a convergent task where you have one expected answer. And here it's more that you have a little project and there are sometimes a few different ways of approaching the solution. And like when I myself became a teaching assistant during my PhD, I was surprised with how much of actual like research in some form this is, and it's already affected since like first year of study. So that's also why Dutch universities are so good quality universities, and they are quite high rated. So it's really I can see why it was so efficient for you to go this way. So that's great. I very much like the strategy, and I actually to some extent I kind of use the parallel of the strategy when I learn about the job market, because it's like I'm learning and then I'm always improving every single time. So actually now I'm learning I'm running an online course for 4 weeks, and last week we had like second session and I was teaching for like almost 5 hours, and during the discussion there came some methods that I didn't really haven't heard of, and people were telling me, you can also read about this, you read about that, because like a job market and the strategies to approach job applications is almost infinite amount. It's there are so many different books and so many different approaches that no one actually knows everything, but actually I got a few tips, so I started reading, and I think for the next edition of the course I'll just put a few more slides with even more information, because some of these things I found interesting, some of them maybe not as much, but and I think and every iteration I know more, so it's also I think to some extent it's similar approach. And I think it's the best approach. I mean, you will never be able to fully exploit all the things you might learn. So this like lean way of learning and doing projects is probably the best approach. Great. Okay, so I think I know how it happens that you became such a pro in data science. So tell us please a little bit about your decision to start your own company. Was it an easy decision for you, since from what I understood, you didn't have much experience with entrepreneurship before? So although like you were working in a company in Hewlett Packard, so you could see maybe business from behind the curtains in some way. But was the decision to start your own company a difficult decision for you? What were the factors that you were taking into account? What other scenarios did you maybe consider? And could you tell us if that was an easy decision, or maybe it took you a while to come up to the conclusion that now or never? So I'm very curious how it happened.
Well, first, I should say that it's definitely not an easy decision. But I always had this idea at the back of my mind, right? Always like, can I start a company? But of course, you cannot just start a company for the sake of doing it. So you need an idea. So I had it in my mind, but I was kind of waiting for something. So not really, how to say, like it had to click, right? It had to click. Naturally, you should somehow solve a problem. This is what I was waiting for. And it happened when I switched to machine learning and started applying to my previous projects. There I saw the value, and I had the chance to experiment with it actually without founding a company. Since I stayed after the PhD with my advisor, so the idea was there, and also I was able to practice the idea. And I saw that it worked. Of course, you still have to convince others, right? Convince customers, etc. But there I saw it. So this helped a lot. This is like the main thing that convinced me that I can do this. But nevertheless, even if everything is perfect, you can always fail, right? So to overcome that idea, my view was to, okay, maybe I can give myself a time slot that I can take this risk and do my best, and if I fail, I'll do something else. So this is how I started, right? Knowing that I can fail, but I'll give my best to it. So it was not an easy one, but a well-thought decision, let's say.
Mm-hmm. And okay, and can I ask you then, what was your wife saying, and also how did you find your business partner? So because you know, like one of the main reasons why startups fail is that the co-founders get into some dispute. So it's really hard to find one thing is what you just said, finding the right problem so that you can actually contribute and it's a real problem that you're solving. And second thing is indeed finding the right people to do it with. So how did you find the right person, and also what was your family's point of view at your business?
So first, how did I find Emre? We met in Barcelona through common friends, and so our let's say talents were complementary to each other. He is an engineer, but he has a lot of experience with management. So all my life, as you said, like it was always technical, and for him it was mostly the business side, actually, marketing, right, sales. So this is why I decided to bring this idea to him, that this is a team sport, and instead of finding someone like me, I'm looking for someone like kind of the opposite, so that we can bring our forces together. This is why I decided to open this idea to him, and this is how we started. And as you said, I would definitely say family is very important. So it's not like a decision on my own. We took this together with my wife because this is not an easy task, right? And sometimes you need to devote long hours to it. And of course, your wife should agree with it, right? Or even if you fail, all these things, all the risks you take together. It's not like I can take the risk and then we share the risk. No, we take the decision together. Luckily, she was on board also. So this is how we started.
Great, fantastic, great. I'm happy for you that you found such a supportive partner. And okay, great. So it sounds like the beginnings were not that difficult after all. So you found the right person, and you found and you had you were on the same page with your partner. Okay, so how did you find your first client? And can you also explain to us, since we so far we just know that it's a machine learning type of projects, but could you please tell us more about what your company is doing today, what type of projects, and what type of interest you have for the future with your company?
Sure. We do three things, simply. The main thing, the way we started was, as I said, I solved the problem for my advisor, right? And I saw the value. So what I offered to him was to found a company and provide machine learning service for his physics photonics based projects. So this is what we do is simply in these projects they build physics devices, let's say photonics devices, measurement systems, very, let's say, innovative materials. And to understand all these, you need physical models, and machine learning can help you by building like a competing data model and see the advantage. So sometimes you can get better accuracy with machine learning compared to physics-based models. Sometimes it's more resource efficient in terms of prediction. Sometimes because physical algorithms, they are sometimes very iterative. You need quite a bit of time to get a result. In machine learning, you move this complexity to the training time, but once you train a model, to get a prediction is very fast. So these are the two advantages machine learning can bring for physics, let's say, but of course also other domains. So this is actually how I got my first client, how we started. But the other things we do are, of course, trainings. So I give machine learning training. And also product developments. So these are, of course, on these different time scales, right? Trainings are very short-term jobs. Projects, let's say mid-term, and long-term is the product development. In terms of the product development, we work with a hospital to develop a dermatological tool to recognize cells, basically, from microscopy images. This is more long-term. So this is more or less what I do day to day.
Okay, this is a very interesting model because I think I can see that you play around with different projects on different timescales, and I really like that model. I'm actually also when I develop my company, I also basically try to put it on a few different legs so that there is more than just one stream of income and more than just one type of product, and there are also different timescales to that. And that I make sure that these projects are synergistic with each other. So I really like what you're doing, and actually, I'm curious. Of course, I'm curious about all these things, but I think that the last one is the most exciting because it has the actually a potential to really change something, right? Because it might lead to another like method for diagnostics. So it has a huge potential, and so I'm curious, like, on what stage is this project, and do you think that if you design certain methodology, then you could also potentially reapply the same way of designing the diagnostic method for some other problems?
Well, let me explain what the project is first. So there is a dermatological test called Sank smear test. So from skin lesions, you can take cells and view them under the microscope. And depending on what cells you see, you can reach a diagnosis. The problem was I teamed up with this doctor from my hometown in Turkey. He is very experienced with this test, but people prefer other tests that are easier to use, but more expensive. They take more time to use, but it's easy because you just send a sample and get a result back. In his case, this test was very simple, very fast, but you need to understand what you see on the microscope. So this was the challenge for other clinicians to use it, right? You need a lot of experience with these images to be able to understand them. So what he suggested, actually he wrote a book on this to be able to motivate people to use it, right? He wrote an algorithm. If you see this cell, it's this disease. If you see that cell, it's that disease. But still, it was not very easy for people to interpret it because you need to see a lot of images to be able to understand.
Okay.
So actually, machine learning was a perfect fit for this problem.
Right.
Right. So this is why we teamed up. This is how we started. And at this point, what we did was a proof of concept model that can actually recognize these cells. For starters, we decided on 6 most important cell types and build a model. And we actually tested this on images from new patients. That is, after we trained the model, we said, okay, this is the final version, let's say, for now. We are not going to touch it, tweak it, anything. And then we'll test it on new images from new patients, not in the data set. And we were able to achieve high accuracy, above 95%, with this. And so this is our current stage. We now would like to add, let's say, more cells, increase some functionality to it to be able to. So this is now like a prototype, and there's a gap between prototype and the product. So we are trying to fill this gap. So this is where we are at, more or less.
Super interesting. But like, can I ask a question from a little bit different angle? Because I'm trying to always like look from different perspectives at the problem, and now I would like to ask from. I'm just trying to put myself now in a scenario when I'm a potential investor, and I'm just thinking, do I invest in this project? And my first question would be, how do you? What's the potential business model? Because algorithms, at least in European Union, the software and algorithms are very hard to protect. So, because if you develop a laboratory test for testing some cells, and this actually, there is some physical parts back to it, or some substance, or some, new solution, then you can potentially patent it. Or if there's any hardware packed to it, but it has to be a physical hardware. Because if it's at least to my knowledge, if this is just a software, then it's really hard to protect by a patent. So my question would be, can you spill the beans about how are you planning to commercialize this product, and what is the business model? Or maybe it's a secret. So if it's a secret, please tell us that. But I'm very curious.
Well, I can tell you some things, right? Not all, but as you said, it's not easy to protect the software. But in this case, what matters is the data set. Because even if you have the model, you cannot improve it if you don't have the data set. So this is, let's say, how we can protect the business. Because it's always, I mean, it's not like, it's never be like, okay, we're done, this is finished, there's no improvement. So you'll always be in need to add more cells. You observe, let's say, some things that needs improvement. So it will always be an iterative process. So you need the knowledge from the professor. You need the dermatology knowledge to exploit this, which he has. You need the data set. You need the machine learning knowledge. So all these things combined, we think that protect us. And there is a question by Rohit. He's asking is there a legal privacy problem to get the data to train? So for us, it was, we had to apply for an ethical commission to be able to do this. But maybe there will be additional concerns when we want to turn this into a product. Okay.
Okay, and I think maybe in case you have a software, maybe you could also build it in this like black box version, so that actually the backend is not visible. So indeed, the model is invisible to the user. So indeed, they don't know what parameters you have in the model. And actually, I'm now working on a battery of aptitude tests, and this is how aptitude tests are basically made in general. So whenever you go online and go and fill in one of these personality tests, like Myers-Briggs, 16 personalities, or maybe Gallup Strength Finder, these popular tests, you don't know what is on the backend. You just get the response on the screen, and you cannot reproduce the test because it's pay-per-click. You pay, you fill it in, you get the response on the screen or sent to your email, but you don't know what is on the backend. So this is a way of protecting this type of intellectual property, and I'm just working on doing exactly the same. So doing pay-per-click version where backend is highly protected. So I know that this is probably the only way of protecting this type of information. Okay, great. And okay, then I have a different type of question now, which is just very practical question about the Corona crisis. So did it in any way affect your business? Because I know that the like small entrepreneurs, and I know I feel it on my own skin, that small entrepreneurs have really hard time these days, or at least some of them. So could you please tell us a little bit about, did it affect you in any way?
For sure, yes. So for some projects, yes. For some, no. The ones I would, so since I'm based in Eindhoven, but working with people from Barcelona, from Turkey, all those things were online already before Corona. And they are still online, and there was no minimal change, let's say, for those projects. But mostly for trainings, this was the problem, because trainings, I was doing them in Eindhoven. So they were either online or not happening. So,
right.
But I can always then focus on my project. So it was not really a big problem, but still some missed opportunities for sure.
Yeah, I can tell, because actually originally the main source of income for my company was supposed to be on-site training, so that was actually hammered to high extent this year. But like, so I can tell. But fortunately, you're doing in machine learning, so indeed, IT as an industry, IT was not a machine learning based oriented companies were not hammered that much this year. I think like biotech was hammered much more as a whole industry. I can tell because also I see the statistics of how easy it is to find jobs, and I think in your area not much changed in that department. Okay, great. So glad to hear that you didn't have any extra difficulties. Well, maybe a little bit. So my question, I would like to now hear a little bit more about like you as a person, and about when you look back at your story, for instance, do you have any when you look back at your career so far, do you have any regrets? Do you think you could do certain things better if you have if you could turn back time, would you actually do something different, or do you think that so far you have a perfect way of developing yourself, and you are on the right track and you've always been? So I'm curious what you would answer to this question.
Well, this is a tricky question.
Yeah.
Because in like retrospect, you can always, it's really easy to say, okay, I did this wrong, did this wrong, did this wrong. But at the time, that was right. So, and at the time you were a different person, right? So it's not really, I mean, I wouldn't answer this question that like, okay, if when I was 20, I would have done this differently. But I didn't have this mentality at the time. So it's not really correct to say that I would have done this like that. No, I mean, it's not. So that's why I think it's tricky in that sense. Like, okay, I could have done things better, of course, but you need to see all these things, right? To be able to do that thing that way. And without having that experience, how can you do it? I mean, so really, I wouldn't change anything, not because it was perfect, but because I cannot.
Right. So you're saying that you did mistakes, but it was not regrets, because
exactly.
Okay, great. Okay, so now the question I would ask you then is, okay, so then let's talk about the future. So do you have any like an image of a perfect life you would like to have in, let's say, 10 years from now? So do you think you would develop into serial entrepreneur, or maybe you would at some point develop one product that rocks the market in that area that you're interested in, and then sell a company? Or what do you have any picture of where you want to get in 10 years?
Maybe I have a loose picture, let's say. I mean, the thing is, especially today, at this age, things change very fast.
Right.
So I would have never imagined, let's say 10 years ago, that I would be at this point. There is no way I would have imagined this. So in that sense, I keep the possibilities open for 10 years later. But of course, there are some, let's say, general principles I live by. So I hope 10 years from now, I'll be still happy from what I do, right? This is the point. I mean, for me, as long as I enjoy it, what I do, like, especially technically, since I'm technically trained, I wish I will do something that gives me joy from this technical perspective. I really like the thinking that machine learning provides to me, all these projects, that I enjoy it. So this is what I want. Whatever I do, this is what I want, I hope, in 10 years. And in terms of, let's say, a bit short-term vision. Of course, I would really like for example, the Sangsmir project to turn into a product and really be useful for doctors and patients. This would be a really nice thing to see for myself.
I wish you all the best. I mean, I really like your attitude, and I also think that it's really one thing that maybe is natural for you, but not for everyone, is the this ability to delegate. Because I think a lot of people have this problem, and I really like that you found the person whom you trust to do the marketing for you, and you are actually willing to share your company with, because that's also not a typical setting. Like, people usually try to delegate marketing to marketing experts, and also that you found this doctor to work with. Actually, on this webinar some time ago, we had a guest, Maria Otworowska, who now works on an app that analyzes the consistency and the composition of skin products in skincare. And she actually, in her business model, she works with her partner. They are co-founders of a company, but they are both coming from computational neuroscience, and they are both heavy on computation and algorithms and programming, but they didn't have any knowledge in medicine. And actually, she took it on her own shoulders to actually learn about the skin and the skin composition. And she said, for her, the main bottleneck was that the information is very messy and it's hard to get to hard data. And then she also, once you go into this industry, so beauty products, there is it's an industry that is very, very hefty and worth like billions of dollars. And there is a lot of practices that are maybe like, shady. And like she had to learn a lot by herself. And I think maybe to some extent she also slowed down her own project because of this, because she didn't really collaborate at that point with anyone. And like, that was also my question for her, that that this is this is a lonely road if you want to get all the expertise by yourself. So it's really nice that you actually found a partner before doing the project. I think this is a very good approach. Okay, so what are your plans for the incoming year then? Because I totally agree that in 10 years it's hard to predict, but I think for 1 year, probably you have some plans on your mind.
Before that, let me add something related to this delegation. I mean, with machine learning, with these projects, there is no way I can do this without the domain experts. The point is, the way I started was with the physics project, the photonics. I know the domain, I know machine learning, and then this I can do by myself, kind of. But even then, I worked with experts. For something as dermatology, I had like zero experience. There is no way I can learn it by myself without these domain experts. So delegation was not my, let's say, choice, or it's like it was necessary. So I wanted to add this. Actually, I want to add that maybe machine learning projects fail because people do not add this domain expertise into their team. They think that they can solve these problems with machine learning. They think that there is the data, and then we apply a model, and there's the solution. This is far from the truth. You always need the domain experts. So I need them. It's not like my choice or something.
Actually, I see that a lot, and like there are a lot of grants for machine learning also, and I see that there are a lot of projects that basically propose there is someone who has a nice model with nice mathematical properties, and they are trying to find as many potential applications as possible. And as long as this sounds good, to the grant committee, then they might actually land money for it, and then there is no validation if this is actually a viable project. It's just based, the assigning grants is based on the research history of the author of the grant. So it's there's a lot of projects. Machine learning is very hot right now. So grant agencies are very fond of this type of projects, and I can see that it's often the case that the whole career of one person is based on certain models that they are trying to basically force into as many problems as possible, even if there is no problem, the problem is made up. So it's really good that you don't do that, because that's not the way to go to actually design any
Definitely.
viable product. Yeah.
First, I would say, like, first comes the problem, then the model. Actually, the model is not the important part. What's important is the problem, and maybe the simplest model, the oldest model, works best for that case. Because so if you have a great model, very novel, bleeding edge, cutting edge, it's actually, let's say, useless, right? It's actually useless because there are much simpler models with less parameters that can solve the problem. So why use that model? So the approach in my case would be to focus on the problem, and then machine learning comes later, I would say.
Actually, it's hard to disagree with anything you're saying, because everything makes perfect sense. I think maybe some people are just naturally also talented for business, maybe that's what you should, maybe that's what you are made for, because I can see, Rohit is saying, but usually it's very hard to find the right model. That's true, but it's still better to first find a problem and then a model than the other way around, believe me, like, even if it's hard. Because otherwise it's just flawed business. And yeah.
Can I add something for his comment, like difficult to find the right model? So the thing is, so to generate value, you have to do many things right. So a project has hundreds of components, and model is an important part, yes, but not the only part, not the most important part. So what you need is to find a good model, not the best one, not the perfect one. No, it's just you need to find a model that works and suitable for the client, for you, for everyone. If you can check these two marks, then you're done. You don't need the last 1% accuracy at the expense of, I don't know, months and then compute power, because there are all these other components you have to get right to be able to make all this pipeline to work. So you need to focus for, like, you need the focus for everything, right? So you cannot just focus on the model. So it's maybe very difficult to find the best model, but not difficult to find a suitable model. And this is what you need.
Yeah, that's a very good point. Again, like, it's hard to disagree with anything you're saying. It's totally, I agree. Especially, if you're solving a problem that no one really tapped into before, like this, if the classification of these cells was never really automatized, then indeed, I mean, it's important to also get the product out, and whether you have like 99% or 99.5% of accuracy, I think it's already very good. It's already a large improvement from what was there before, which was nothing pretty much. So, so yeah, especially in that type of problem, then. But I totally agree with you. It's also it's like in this business intelligence, you have to take the time factor into account. This is something that we are not being taught in academia. Like, they tell us, you have to make the project and the model as perfect as it can be, and they don't tell us to take this variable of time into account. And once you develop a company, you always have to learn the time management, and it's great that you have it. Maybe it's also, do you think that this time management is also something you learned in Hewlett Packard, perhaps?
Not really. I don't know if I learned it somehow. I mean, if you dissect the problem and look at it, it's just, you see it, right? It's not really something I learned. It's more, what I do is I just take a step backwards and then just look at the problem and think about it critically. This is the thing. So it's just, then you realize the time problem, you realize the pipeline problem, all these things. If you look at it, I mean, let's say what you learn with PhD is to, okay, there's a big problem. You can, how should you approach this problem? You learn the approach. And then, of course, you divide it into sub-problems, and day by day you try and fail, you try and fail, you try and fail. Since no one ever solved it before, of course it's hard. That means you cannot be successful in day one. You will fail, and then in the end be successful. So you learn to cope with it, basically.
Okay, great. Okay, so let me now ask you this question about different aspects of running a company. So since you started, is there anything that surprised you about having a company? Something that you never read in any book about entrepreneurship or business, and something that some little change to your life that you had to introduce, or something surprising that happened to you, or some maybe change in your mind, like mindset, or anything that you couldn't predict before you started the company?
Well, I can say that, for example, even simple things are even hard. I'm talking about non-technical stuff mostly. For technical stuff, I already had the experience, but for non-technical stuff, there is nothing easy. So you always have to spend time on all the details. Even, let's say, renting a space. Very simple, right? You wouldn't consider it to be a challenge for building a company, right? But even that it takes time. You have to find the right place. You have to talk with people. You have to see this place, that place. This was the surprise, I would say. Like, of course, you know that you have to rent a space, but you never think about it, right? So this is just one example. But then there is all this accounting, marketing, building a website, social media, all these small things that you already somehow know that you have to deal with it, but you never really think about it
right
in detail before founding a company. So this was the biggest, I mean, it was not a surprise, but it was let's say, an awakening, right? So this was an interesting thing for me.
Yeah, I totally, again, like, I totally agree with you. And also, the standards are also different. So let's say if you, as a researcher, you send an email to some researcher you don't know, just because you are interested in the research, you're interested in collaboration or something like that, then if you make a typo in the email, no one cares. It's just a typo. But when you looking for a client for a company, and you send a informational email and just asking for opportunities, and if you have any typos in the email, like, they would just not take it seriously. They would take it as scam. And so it's like even little, like, smallest details all of a sudden start to count. And I was also shocked when I realized that I have to actually be vigilant, like, 24/7, because every little mistake can actually backfire from now on. So it's indeed it's much more it's much more hassle. I totally agree with you. Right. And okay, so I have that maybe we should start wrapping up. And I usually ask this question towards the end of the webinar, which is, what do you think you could say to early career researchers who are now at the point when they consider careers in industry and in general, someone who is now in research, and what could you say? Also, people who consider running their own companies. Is there some particular advice that you could give to those people?
Well, what I can suggest is to talk with people who you would like to be in their place, right? If you want to build a company, try to find people who did this, who followed a similar track with yours, and then did this, right? Or if you want to go to a company, let's say you want to go to ASMR, find someone there and try to speak with them, their experience. So this would be the primary thing. Actually, this is what I did throughout all these steps, right? Before PhD, I found PhD students and asked about their experiences. So during PhD, I found people working in the company, during startups. And actually, now that I did this, there were people reaching out to me already who did PhDs, but then looking for alternative careers, and they were interested in building a startup. So I would say this is very important, not because that the things they would say are necessarily right, but you can get a different perspective, right? You can never get that perspective just by sitting and thinking about it. So if you just listen to them for 30 minutes, you can just get something that you never thought about. So this would be my primary advice, I would say.
Yeah, that's very, very good advice. Actually, networking among all the methods for looking for jobs, networking has probably the best conversion rate. So you can get the most out of it per hour of your time compared to answering to job offers online and things like that. So I totally agree with you. Actually, it's hard to polemize with anything you're saying because it's so rational, everything. I can tell you, sometimes you just meet people who are overly intelligent, but not just intelligent in terms of IQ, so that they can solve some mathematical puzzle quickly, but also like have wisdoms on different levels, so they can zoom in and out from problems, and they can steer themselves on many different levels, so they can solve a particular task efficiently. That is very focused logic task to solve, but they can also make decisions in these different on these different levels, and they are good decisions. So I'm really happy to see that you're one of these people, and it's not very common actually, so it's really interesting. And I'm looking forward to see how you will develop in the future, and how your company will be developing. And I'm curious. I'm also curious, but you already explained that you're not planning too far ahead. And I think
Thank you very much for your
very
kind.
entrepreneurial. Okay, so great. Is anyone else willing to ask some questions? Because if not, then I think we'll slowly come to the end of this webinar. So okay, so if that's the case, then let me just say thank you guys so much for attending the webinar, and I would like to cordially thank to Alican for sharing with us. I think it's super interesting, and thank you so much for joining us today, and also for people who are watching this material online. Please, if you guys like this type of content, then I'd like to encourage you to subscribe to this channel, and also comment, please, because we will take the questions. So if you have questions, or you can find Alican through LinkedIn. So please take your chance. I think this was a great lesson of business intelligence, and I'm sure that Alican will be happy to take your questions. So thank you so much, Alican, and
thank you, Natalia, for the chance. And you can always reach out to me if you have any questions.
Yeah, fantastic. Thank you so much, and good night, guys. Thank you so much.